Hi everybody. For today's lesson, we are going to do the culminating activity for our bridge design and construction unit. The objective of this lesson will be to test your bridges to failure and collect data on how much weight they can hold before they fail. We're also going to do some reflective questions after testing, and that will actually be used as your summative assessment. The materials for today you will need is the finished balsa bridge constructed by you and your partner over the last few classes. You're also going to need a scale that weighs in grams. You'll need a luggage scale, which is that blue object on the desk. You're also going to need the red wooden block and red hook. Those are our testing rig, which we'll hang our bucket from. You'll need the testing table itself, which is the testing table with the blocks. You'll need the blue bucket, which is where we're going to fill with sand and weigh the bridges. Off screen, there is a bucket of sand and a scoop. And you're also going to need 2 sheets of paper. The first sheet is our actual bridge design worksheet that we did off of the computer that shows our bridge design, the component details, and then also the price and the number of times we had to try to get our bridge correct. The other sheet we're going to have is your actual assessment sheet. This sheet you will fill out on your own. Up top is the data collection in the box, and down below are the reflective questions. To get started with our lesson today, you'll see in the box up top, number 1 is asking you to fill in the cost of your bridge, and it says to use the price from your printed design. Going to our other sheet, if you look at the sheet here, we have a deck truss bridge, and the price at the bottom, as it states, is $221,069.98. So that price of $221,069.98 is what you'll write on line 1 for bridge cost on your assessment sheet. The second step says the bridge mass in grams. Grams is important here, so we will use our scale for that. To weigh your bridge's mass, we will turn the scale on, and it says hello. Hi, Mr. Scale. And you'll want to make sure that it says 0 and that there is a G present, showing that we're in the grams unit, not any other unit. To test this, you will just simply put your bridge on top of your scale lightly. Do not push down. And you will give it a few moments to level out. Sometimes it bounces around between numbers. Right now it's bouncing between 3 and 4. It's spending more time on 3, so we're going to call this 3 grams. So on your paper, what you will do, where it says bridge mass, you'll write down 3 grams. Once you've done that, we will clear off the bridge, or clear off the scale, turn that off to save some battery, and get it ready for the next group. The next portion on your sheet that it's asking you for information is the total weight held, also grams. This is the fun part. This is where we get to test your bridge. In order to do this, we will set your actual bridge truss onto the testing blocks. Now, this particular design is a deck truss, meaning that the truss support structure is underneath the road deck. If it were above the road deck, in this case it would be a through truss, where you would set it above like this. However, since this one is a deck truss, we will have it hanging down below, centered in the middle of the testing blocks. The next step is to take our wooden testing block and the red metal hook. We will connect those together. This is what we will hang our bucket from, and we place that carefully down through the middle of our bridge. We have designed the opening in there, and we will center this block in our bridge as well. So we have that hanging. The next step, you gotta go down under the table, take the handle of the bucket, very carefully and gently hang it from the hook. We don't want to drop it on there because it will add undue shock to your bridge. It could potentially break it before we start testing. If your bridge holds the bucket and the testing rig, you automatically pass. The level at which you pass is dependent upon how much weight it holds and its efficiency rating, which we'll get to in a moment. In order to start actually testing your bridge, you're going to need to start adding sand. So we'll take our bucket and our scoop, and we're going to add some sand. We'll add very carefully and gently, so try not to drop it all in there at once. You want to pour steadily, nice and smooth. You're going to keep adding sand and adding sand and adding sand until your bridge fails and drops down through the opening. When it drops, it should fall into the bucket. So at the very end, you should have a bucket of sand with a bridge and a testing rig inside. Once you have done that and it has failed, you will pull the bucket out from under the table. You will need to carefully pull out any balsa wood pieces that are inside. You do not want to weigh the balsa wood. You only want to weigh the bucket, the sand, and the parts of the testing rig. Once you have all the balsa clear and out of the bucket, you will set it on the floor, and that is when we grab our luggage scale. You'll need to turn on the luggage scale, and when you turn it on, you'll see that it is measuring in kg, or kilograms. A kilogram is equal to 1,000 grams. So to get our total weight held, we'll need to take the reading of our bucket in kilograms and multiply it by 1,000. Okay? So to do this, we have a hook on the bottom. We simply bring the handle of the bucket up, hook it on, and lift carefully. When it's ready, it will beep, and it shows 1.6 kilograms. So 1.6. If we take 1.6 times 1,000, that is 1,600 kilograms. So on our sheet, we are going to go to number 3 and write in 1,600 kilograms. You would obviously write whatever your weight rating is. The next step is, it says here, step 4, your mass, which is the mass of your bridge from number 2, times 4.45. This little equation we do, the 4.45 is a factor that helps us with the efficiency rating. Okay? So we take the mass of our bridge, which was 3 grams, times 4.45. To actually get our efficiency rating, we're going to take the answer to number 4 and divide it by number 3, which is the total weight held. So you take this answer, divide it by the mass that your bridge held, and that's going to give you your efficiency rating. The higher your efficiency rating is, the better. Efficiency measures the ratio between the weight of your bridge and how much weight it can hold. The goal is to have a very lightweight bridge that holds an awful lot of weight before it can break. You will be graded based on your efficiency score. We said earlier that if your bridge can hold the bucket in the test rig, you pass. But your score is based on your efficiency rating. The higher your efficiency rating, the closer to 100 your efficiency score is, the higher your grade. Okay, we'll be categorizing that in bands. Once you have all of this data collected, you'll need to clean up all of your testing materials so the next group can start. It is then your time to start the reflection questions. You'll do these all on your own, answering, as the directions say, in complete sentences. You'll have to answer questions on where did your bridge fail, what surprised you about your testing, what worked well and what did not during construction. And for number 9, you're going to have to refer back to your hypothesis. Last class, we made a hypothesis on your pre-testing sheet that you had to predict how much weight your bridge would hold. This is your chance to reflect on that. If you were correct, you can explain what you think, why you think it held that much. If you were incorrect, it's asking you to explain how far off were you. And the last question is perhaps the most important. If you were to design and build another bridge truss, what would you do differently and why? Again, you must answer these questions all in complete sentences. This paper is due by next class. And again, it is your summative or final assessment. This grade will go into the 70% portion of your gradebook. Thank you very much, guys. Have fun breaking, and have a great day.